Hi everyone, my name is Xinyu Fu. Today I'm presenting Blink, Multimodal Large Language Models Can See But Not Perceive. This is a joint work done with UW and AI2. Multimodal large language models such as GPT-4 and Gemini are so powerful and famous nowadays. They can talk to people, as you can see in this OpenAI video screenshot. They seem to be able to think as humans do. For example, I asked GPT, did Aristotle use a laptop? GPT is clever to say no because Aristotle was a Greek philosopher and laptops was developed after his time. They can see the world. This is my cat, and I asked GPT, what can you see? And GPT-4 can perfectly answer what he is, and he even looks a little bit annoyed. Now, as ambition people, I start to wonder, are these models really that good? Can they really do all these things? So I started to test a few examples by myself. I wondered if multimodal large language models can understand the 3D space. So I asked it a question, is the camera moving towards left or to the right to go from the first image to the second image? As humans, we can easily tell that it's moving to the left to go from the first to the second image. Surprisingly, GPT-4v doesn't get it correctly. It thinks it's moving to the right, and Gemini simply doesn't know. Now I thought, okay, maybe this example is just too difficult for these models. What if we try a simpler one? The next question I give it is, which bounding box localizes the pizza better? And I give it two boxes, A and B. Now, as humans, again, we can solve it within a second. Definitely A is the correct answer. Surprisingly, both GPT-4v and Gemini Pro thinks B is the correct answer. I haven't given up yet. I tried another example just to give it a final shot. I give it a jigsaw question and ask which image fits in the missing part better, A or B. Now, from the patterns of the letters, we can easily tell that it should be A that fits back to the missing part. However, GPT-4v and Gemini again answers them incorrectly. So what is happening here? Can models really see as humans do? Do models perceive the world as humans do? What's the difference between models' visual world and humans? To answer these questions, we propose Blink benchmark. As you can see, this is a summarization of the tasks collected inside Blink. Blink is a new benchmark to test the multimodal model's visual perception ability on problems that humans can solve with a blink of an eye, and that's why we call it Blink. Blink benchmark contains 7,000 unique images, 3,800 multiple-choice questions over 14 different visual perception demanding tasks. As you can see, the questions are evenly distributed over the tasks that are ranged from low level to high level and pixel level to image level. Blink has 3 unique features. For example, the first one is Blink includes diverse visual prompting instead of using text prompts only. As you can see, we use circles to represent points in the space. We use bounding boxes to localize objects, and we use masks to represent regions. Blink goes beyond recognition, while previous benchmarks focus mainly on recognition. For example, we ask 3D questions such as, is the camera moving clockwise or counterclockwise? Which point is further? This is a 3D depth problem. Which point is darker? This is a reflectance estimation problem. Also, Blink only requires visual common sense to answer instead of domain knowledge. For example, which image is real? You don't need to go to college to answer this, and the answer is simply the right one. Which image is more similar to the first one? Without thinking, and within 1 second, we can simply tell that the middle image looks more similar to the first one. We tested a large set of multimodal large language models on Blink, and as you can see, the results show that the models are just far worse than humans. The light pink circle are human performance, which is in average 95%, while the model performance are in average hovering around 42%, while the random guess is 37%. So they're slightly better than random guess, but far worse than humans. Even the best model, GPT-4V, still perform a lot worse than humans. The performance starts as wonder, like what are the common errors between all these models? How do visual prompts affect the model performance, if any? And can specialized CV models solve the tasks inside Blink? The answers to those questions can be found in our paper, and this is a link to our project page where you can find the leaderboard and the paper details there. And last but not least, many thanks to our amazing collaborators. We won't have this work done without all of your help. Thank you for listening.